So what I want to cover today, before I get into the specific topics, how many of you know, sorry, I didn't bring the clicker, I thought there would be a clicker here. So I need to go back and forth to turn up and down on the slides. StubHub is an eBay-owned company. Some fun facts, just for you to understand. It's fully owned by eBay. We are an e-commerce ticket marketplace, secondary ticket marketplace. And of course, with a bigger vision to get into something social, I'll talk about in a second. Some of the facts that you might be interested to know. We have about 25 million users and growing, and sell about ticket per second. This is again, StubHub is just a marketplace for secondary tickets. We don't actually sell tickets. We enable the marketplace for buyers and sellers to exchange tickets, right? Much like eBay, which does for tickets. And we have about 8.5 million page views per day. And interesting fact is, I know we don't, the data seems, size seems not so big, 1 terabyte of data that we process in a month, but that's only because it's transactions. What we're now getting into, you will see, is all of the social data, logs and clickstream and everything else. The size will tremendously increase in our big data platform that we built. Approximately it's about 300 SQLs a day, and just to get you an idea about the number of transactions and the volume that we get. Now, what I want to cover today is some of our use cases where we're getting into where the big data comes in the picture, and what were the challenges that we had, and some of the approaches that we took to solve that problem. And I'll leave some time towards the end to ask you questions. Before we get started, I want to spend 30 seconds on some of the demystifying the terms. This may be only obvious to most of you. So, what is really big data? Is it really big? Is it why it's called big data? The data is big? Well, certainly that's one part of it. The volume or the size of the data is certainly one part of it. But what is also important is what I call the 4 V's of the big data. The variety, the type of data. What makes it so big is the type of data. It's not structured. Sometimes it's structured, sometimes unstructured, sometimes semi-structured, different formats, different types of data, right? Second, of course, is the volume, the size, which really what makes it big. And then the velocity, the rate at which things change. In a transactional world, a traditional database world, you might have hundreds of transactions per second. But in this kind of a world, especially if you think about clickstream, logs, and social, millions of changes per second. That velocity should be able to handle. And finally, the veracity, the truthfulness of the data itself. This is what I call the 4 V's of the big data. And as people refer to Hadoop these days, it's probably become a household word, but typically what people mean is the whole ecosystem. It's not just the MapReduce framework, it's not just the HDFS, it's just the whole ecosystem that people refer to. It's still evolving. A lot of the tools are evolving, and how the traditional data warehouses and the big data platforms will merge is also still evolving. So the question is, how does the traditional data warehouses and what's the long-term plan look like? As you know, for the past several decades, people use data warehouses to store data for business analytics, reporting purposes, and analysis, right? And the challenge is they typically only can store structured data, like for example, transactions, right? And like I said, a lot of the data these days, to understand your customer, is not about transactions, but it's about their behavior, what they're trying to do. How do you ingest, how do you bring the data back into the traditional data warehouse? It's hard. And data is primarily the biggest asset for any company. The more the company leverages the data, the better they can serve their customers, right? So how do you leverage that? Now, so what are companies trying to do? So is the database going to go away? Probably not, right? They're going to stick around for, at least in my personal opinion and what I've seen from the industry and what we're doing ourselves too. It's going to be there for the next at least 2 to 3 years, right? Where the processing is going to happen. People are beginning to, for the last several years, beginning to bring in all this data, both transactional and non-transactional data, into big data platform. Process it there. And for reporting purposes and for analytics purposes, you can always push the data back from the big data platform into the data warehouse. That's kind of the mixed, what we call the hybrid approach that we have followed, that we're following, many companies have followed too. But of course, any company that's starting fresh right now in internet, if you talk to Facebook, if you talk to some of those companies, they might say, hey, we're only using big data and not data warehouse, right? Any company that has some transactional e-commerce plus the social combination, eventually will, of course, will have just the big data, but today it's a hybrid model. What's the long-term direction? Well, it's anybody's guess right now, but what we feel, what we think where the industry is headed is that 3 or 4 years from now, pretty much everyone will be starting, hopefully by that time, a lot of the tools and the frameworks with the big data platform also would have evolved, more mature, stable to make that happen. Now, switching gears, remember I said we had some use cases that we needed to solve to go build the big data. So what's our real big vision where we're changing to? Remember I mentioned at the beginning that we are a secondary ticket marketplace. Today what we do is you can go there if you're a seller, if you have something, if you have tickets to some events that you bought, but you no longer are going to go, you can go there, just sell it. You still keep the tickets, and then we make that available to buyers who can go and buy, right? That's a marketplace. Where we are going to, our vision is to get to a place where, to make it as a purely the destination for all fans, where they're not only coming to just buy and sell what they want, but to discover. For example, you're today attending this conference, let's say you're in the evening, you go to San Francisco, you're in the city, you're looking to do something. Start from there, I'm looking to do something. How do we drive you to find what you need to find? Based on your preferences, based on your location, based on your history, based on your mood, based on the conditions, all of that stuff. How do we allow you to discover what you want? How do we then allow you to access, to go get event tickets for those events? And finally, how do we allow you to share the post-event experiences? As you can see, the data now that we're talking about is not only just about transactional listings and the tickets, it's about the discovery aspects of it, it's about the sharing social aspects of it, and a variety of data that's coming in. That's our vision. As a result of that vision, we have a bunch of use cases that we needed to create and support. Obviously, first and foremost is personalization recommendations, right? As a user comes to the site, based on a number of things that I've already mentioned out there, you want to do personalized recommendation. In real time, how do you do that? How do you process the data behind the scenes in real time, do the personalized recommendations? For buyers, same thing for sellers. If you're a seller trying to sell something, how do we recommend you what's the right price for you to list at? Things of that nature. And then the social interactions. Remember I talked about the entire life cycle of discover, access, and share. And in order for you to discover quickly, it may not be just a search. It might be based on a variety of other factors. How do we allow you to do the social interactions on the site as well as the mobile native apps? And of course, the traditional use case about business analytics and fraud analysis, that includes fraud analysis, about reporting, understanding the behavior, and reporting giving the reports to the CFO, and so on. Finally, the customer, what we call the customer 360, to understand the customer better. That's the big data is all about that. How do we understand our customer better, right? What are the interactions that they're having on the site, either on the site or on the app, or on other places out there? How do we allow them to, how do we understand their behavior so we can recommend them and serve them better? This includes clickstream, transactions, logs, segmentations, and outside metadata. There's so many types of data sources that we're talking about. So the challenge is, as we have about 20 plus different data sources that come from. We're not unique in that. I'm sure every company these days has lots of varieties of data that's coming in. Each of them is of different type and variety. Remember the 4 Ps that I talked about at the beginning. And they all change at different rates too. And they don't necessarily have all structure. Think about social. So if somebody logs in with a Facebook comment, now the type of data that you're going to get, the social behavior, the interactions, the friends, the graph, the information is very different from their interaction on your website when they start clicking on different sites and different links out there. How do you capture that clickstream? It's very different from they actually purchase. We have a transaction which is relational table data. Very different from log files, very different from Acxiom, for example, segmentation data, user segmentation. How do you do that? That's a challenge. How do you ingest? How do you bring in there's varieties of data of different formats, shapes, and sizes into that. Structured, unstructured, semi-structured, right? Now, the other challenge is this is no longer just an offline processing as traditionally it used to be in the data warehouse. You need to bring the data back into the OLTP online environment on your website, on your mobile apps in real time. So you can surface that back to serve the customer better, to present the right information to the customer, right? That's easier said than done. How do you bring this back in real time to your application? And and I've said this already a couple of times, you can still store aggregated data through the data warehouse for reporting purposes. That goes on. That's an offline process out there, right? But what if your aggregate data is not a structured data? What if it's a graph? How do you store that graph in a data warehouse? Right? The example of a graph is, a person who has seen this, a person who has visited this event, has also visited the other event. And then you're constructing a graph. How do you express that graph? Sure, you can express it, you can work on create a table for a graph, but how do you represent that in a data warehouse, right? And of course, updates to existing processes. This is one of the reasons why, as I said in one of my previous slides, it's going to take a few years for this platform, the big data ecosystem, to completely take over what existing processes in data warehouses do. But we pretty much, for the most part today, people are following the hybrid approach that we described. And secondly, in our particular case, obviously, if you're starting fresh, if you're a new company startup today, you're going to do everything clean, right? But companies don't always start off like that, right? So we've been around for 10, 15 years now. Things get built over time. They get patched up over time. You have a lot of processes and tools out there. How do you change them, update them, while you're putting this new system in place? That's always a challenge. And of course, while we're building this for the future, the use case and the vision that I talked about, we obviously have to support our current functionality of allowing the users to interact and transact out there. These are some of the challenges. Some example data sources, which I've already mentioned, which is your transactions. This includes orders and listings, sellers who come in and list and buyers buy. And that's where marketplace, like I said, it's an e-commerce platform. Catalog, this is one of our biggest assets. Millions of events, millions of types of things that happen across the globe. And that's structured, it's somewhat structured, more or less. And then now, of course, Siebel, customer help records, and all of that, those are all structured here, pretty straightforward. A lot of the sources, majority of the 20 plus sources that I talked about are semi to unstructured. This includes clickstream as in people coming in, interacting on your site, interacting on your native app, things like that. External segmentation data, we use some external data sources for that. Survey data, I'm not necessarily going to read all that. Social, because of the social interactions, we do that. And meta classification, moods, as we talked about. How do you say, hey, this is a kid-friendly event, this is a family-friendly event or not? What's the meta classification for those? How do you get that, right? And referral data and so on. So these are all the different sources we have. This is not an exhaustive list, but I wanted to give some examples just for you to get an idea. Now, the solution that we're put in place, and obviously there are a few qualities that we look for. First and foremost is manageability. As one thing is certain, the list of sources that I talked about, they will change. They may not be constant, they won't be constant, that's for sure. They will change, some more will come and maybe additional, some will drop off. How do you easily manage? And then remember the velocity, the rate at which the data comes in for each of the data sources is different. How do you easily manage that? And of course, we wanted to be, especially in the big data platform, we wanted to be open source compliant. We didn't want any proprietary interfaces and frameworks for the simple reason that things are so evolving, so every single day things are evolving. We cannot be stuck with a particular proprietary stable. Scalability, we're an internet company, so the rate at which our data grows is tremendous, so it needs to be scalable. Integration with user relations. The biggest problem today with the big data platform system across the globe, it goes without saying, is a lot of the traditional visualization tools that we have today on the data warehouses, whether it's business objects, whether it's MicroStrategy, whether it's Tableau, whether it's pick your favorite tool. A lot of those tools don't necessarily work well out of the box with Hadoop or big database systems out there. So what is your option? What are your options for exporting and visualizing your data from Hadoop to whoever is looking at the reports out there? Because there are some tools, Tableau in particular actually has a Hadoop connector that works out of the box, but not every tool works out of the box like that, right? But we look for frameworks that support, that come out of the box with capability to integrate with some of your existing tools out there. It's very important, rather than requiring you to go buy new tools. How does it work with the existing tools? And finally, the last two is about data imports and data exports. How flexible is it to import? How quickly, how frequently can I import my data? What format does it need to be in? And can I automate that? And similarly, how flexible is it to export it? Remember we were saying, even though the data sits in Hadoop and HDFS and other formats, HBase, wherever you want to store it, you might want to ultimately export it to other places, maybe to a sandbox environment, maybe to a data warehouse, maybe to an analytics engine. So you need to be flexible to export this data into these multiple sources out there. These are the qualities we look for, and ultimately we actually settle with, after looking at some of the things, we actually use Hortonworks. Hortonworks is the open source Hadoop framework and ecosystem. It's currently at 2.1, so good. And so we use that ecosystem. What I want to briefly talk about is the system, what we built. What's the hybrid system that I talked about at the beginning? Combination of data warehouses and the Hadoop ecosystem. So I'm going to go over here. So as you can see here, this is our big data platform. At the bottom here, I'm sure you probably can read from distance here. These are all the different data sources that I was talking about. 20 plus our number of data sources. They're all coming in at different rates. They're all coming in at different velocities and different types. What we have is what we call a data adapter framework. And in fact, my colleague John here, he's going to speak a bit more detail about this in the afternoon. There's another session at 2 o'clock, and I encourage you to attend that. So this is a framework which actually uses Flume and a bunch of other streaming technologies to stream data coming in through these multiple different sources. And we have a base framework and then individual adapters for each of the types of data sources. They ingest, bringing the data into the Hadoop, which is the Hadoop file system, HDFS out there. All of the things that you see above there, a lot of them are the traditional open source frameworks and tools that you use, like Hive and Pig and Mayhelp and so on. The things that you see here, two of them, MapReduce, Service, and then the data validation, these are the frameworks that we did internally. At some point, we might actually open source them too, to validate the data that's coming in and allow you to automatically submit and run your MapReduce jobs to aggregate data and so on. And this is the typical big data platform out there. Our contribution, the thing that we've done, is the data framework. The interesting part here that I wanted to mention is that this is your traditional data warehouse, enterprise data warehouse. Today, in the absence of the big data platform, data comes in, transaction data comes in through some sort of an ETL, regardless of which ETL you use, Informatica or whatnot, and then go to the data warehouse. What we're now saying is, yes, the transaction data will still go into the data warehouse, but the way it even goes is that there is some common ingestion adapter framework, which will do all the common things of cleansing and delooping and the common aspects of it. And then the ETL will still go and insert into the data warehouse. But the same data also goes into your Hadoop big data platform out there. And why? Because a lot of the times when you are doing analysis, you not only want to understand all of the other social aspects, but you actually want to know. If you want to query, of the people who are visiting all these events and who have been doing all of these things, how many of them have actually purchased or bought anything? Where do you get the data from? How do you correlate this across these data sources? So this is still the source of truth for all of the data coming in, but transaction data still goes to the data warehouse too. And this can be very productional. We can publish some of the aggregate from the data warehouse back into the Hadoop system and vice versa. If you have a MapReduce job that runs on Hadoop and has the result aggregate can be pushed back into the data warehouse too. That bidirectional connectivity exists. And then finally, where do you put the results of your MapReduce, the results of your queries? You can put it into something called an HBase, which happen to be the NoSQL database that we chose, which seems to work pretty well. I've got to say about it towards the end. And you can also push that to your search engine. Solr happens to be the search engine that we use, which is an open source version of the search engine. You can also push the results and aggregates from your big data into the search directly. So when a user comes to your site or your application, the data is immediately available in real time. So this is the big data part of it. Now, the other aspects, how else can you do it? So this is your OLTP environment, like our website, your native apps, this is your online transaction processing system. So the question is, this is offline, as you can tell. All of the data is coming in, you're processing in Hadoop, and this is happening offline, not in real time. Question is, how do you push the data from this offline systems into the online system back here? This is through application. So this is your online. You have your search engine, like Solr in our case. Could be a different engine for you folks. A NoSQL database, and you have other databases and services and so on. I'm taking an example here where we have what is called a recommendation service. When a user comes to our site, when a user is interacting, you want to recommend something to the user. So there is a recommendation API service. Where does it get the data from? It needs to know the past behavior, interactions, and so on. And that's probably has a MapReduce job has produced the result into the HBase. Now that gets replicated into another HBase over here, which is an online system with the exact same data, which is then directly accessed by the recommendation API. Same thing for Solr. This is an example. This is not a prescriptive architecture. This is an example which is trying to show you that this hybrid approach or this real-time big data nature of it allows you to export your data from your Hadoop MapReduce to a number of different choices and channels and products, depending on which one you are using out there. What I'm not showing here, there's another option where the data is directly going into your HBase here instead of going, and you run some sort of MapReduce there in the file system there. That's also possible. We're looking at those options too. Finally, one other thing that I want to point out, your analytics, traditional analytics world, people who are scientists, they want to do algorithms and analysis on your data, whether it's for fraud, whether it's for business, for whatever reason that they're doing out there. How do they do that? So they typically use products like, if they're using open source Mayout, or they're using commercial Oracle R or things of that nature. What we're saying is the data from the data warehouse and the data from the HBase in the core system can be replicated to what we call a sandbox environment. And the tools like your analytics engines and tools can work on top of the sandbox, so they're not working directly and modifying, changing anything in the production environment here. And so that's, they can create reports out of that. Finally, the business intelligence reports, remember the tools that I talked about traditionally, whether it's Tableau, MicroStrategy, or whatever other tool that you're trying to use there, they can be pointed at. Today they're pointed to data warehouse. Some of them are capable of pointing to HDFS in Hadoop out there. But if you want to continue to stick with some of the existing tools that cannot work with Hadoop, the option that you have is to export the results of your aggregation back into the data warehouse, so your existing tools will continue to work on the data warehouse. That's the hybrid approach that we have followed. It seems to work pretty well. And based on my discussions with some of the other industries and internet companies, and pretty much everybody seems to be following this type of scenario. And of course, it remains to be seen over time how this will take over, and traditionally, slowly, the data warehouses the existence of that might slowly fade out. Now, the same thing presented differently in a component view that's in a bit more less technical way is, think of it as a component diagram where we have all of the sources at the bottom, data sources at the bottom, and we have the data platform. This includes all of this is the diagram that I was showing you in the previous slide in detail. All of the data imports and ingestion frameworks, analytics engine, and data warehouse and data marts. Data marts are things that you create specifically for a particular business unit, particular organization to do the analysis on that. So this is all the data platform. And then above you have all the consumers. Data sources, platform, and the consumers. We have our e-commerce sites, we have new experiences, we have analytics, and all those are there. Orthogonal to all of that is what we call the metadata management. For example, where are your schema definitions? Who maintains and owns the schema definitions? And what is the source of truth for that? And what is the governance process around that? And so that's all the metadata management and master data management. At enterprise level, of course, we have them. You don't necessarily use any different tools for all these three, but these are some of the processes that we built on top of our existing things to ensure data consistency. And when the data warehouse says that this is the schema, this is what wizards means, Hadoop is not saying something different. It actually says the same thing. So how do we ensure the definition is the same across that? Those are the things that we use out there. Finally, one quick word on Hadoop NoSQL, as I mentioned earlier. So we use a couple of different NoSQL databases out there. One is for Mongo, where the user is interacting and they're storing some of their likes and favorites and so on. So JSON document-oriented NoSQL databases is Mongo. The second was, which I referred to in my Hadoop diagram, was HBase. This is part of the ecosystem for Hadoop, where if you have a MapReduce job, you have queries out there, you need to store the results in a table-oriented column database, kind of similar to structure. This is the closest NoSQL database that comes to a structured database, which is linearly scalable. And you can have, instead of having an eventual consistency, you can have intermediate consistent results out there too. But it's scalable and horizontally because of its architecture. And that's what we use today. Now, that's pretty much what I wanted to cover. But we have a few minutes of time. I'm open for any questions anyone want to have. Any questions?
Yes.
Yeah.
So, in your architecture diagram, you had import section. Are you running those in MapReduce or are they just functions of getting source data, manipulating it, and giving it to the Hadoop in a way that you can?
So, great question. I'll repeat the question for the rest of the term. Is the import section, is it actually a MapReduce or is it just bringing in the data, validating and putting it out there? The answer is the later. Import itself is not a MapReduce, right? You can write a MapReduce if you want to, but the purpose of import is to bring in the source as it is, validating it, inserting it into your HDFS. You can further then write a bunch of MapReduce to transform the data into the format that you want. So the answer is, if you import is just bringing all of the data from the sources, put it there, and then I'm going to run my MapReduce, you have that option. But if you say, no, as part of import, in line, I want to transform something, that capability also exists, but we don't do that today. Because we want to have the original raw source truth in place first, and then apply the MapReduce on top.
And you mentioned Hortonworks. Is that import there? Is that what you use?
Yes, Hortonworks is the open source distribution for Hadoop ecosystem, but the import layer is what I call the data adapter layer. That's something that we built. In fact, John Michael here, he and the team built that layer. It's based on, again, open source Flume and a bunch of other things too. Sometime in near future, we might actually open source that ourselves, because there's nothing really particular, special or custom to us in that framework. By the way, before I forget, I have a couple of Warriors tickets, free tickets for Sunday that I'm going to give away. If you guys put your either business cards, email address in here, we can pick a raffle and a couple of tickets. I have 2 tickets that I'll email it to you. So I need your email address, so either business card or email address, you can drop it there, we can do a raffle. More questions? So the question is, what have we done to help sellers to get the information to them? We do a number of different things, apart from the fact, like 2 things. One, is A, how are they performing? So sellers, especially some of our large sellers who are doing a lot of listings and whatnot, they want to know on a daily basis and a weekly basis, sometimes on an hourly basis, especially for events like Super Bowl, right? How are they doing? How are things changing for them? What's working? What's not working? How is the rest of the prices changing in the overall in the market, right? We give that information to them. The second is about pricing recommendations, which is to say, well, you have a ticket. Let's say you have a ticket to a Giants game, and you're not going and you want to sell. You don't know how much to sell it for. So, I mean, individual ticket is probably an exaggeration, but if you're a large seller, you have lots of things to sell. And based on the historical data, based on the current trends and what's happening out there, and what is the likely good price for it to go quickly, for example, that kind of recommendations we can give as well. So both aspects. Yes.
So, based on your diagram, your map will produce the results sort of in pages.
Yes.
What I'm trying to do is, when you get the results, let's say, suggestion, and if the user says the suggestion is correct, this is not correct, would you put that back to the import and put attributes, or would you put that the increase and put the attributes around the half of the increase?
So if I understood correctly, let me paraphrase the question for everybody else. So one example, I'll try to put this in an example fashion. User is interacting on the site, clickstream data came in through Hadoop system. We ran a MapReduce job and produced some results of some recommendations to the user. Now the information goes back to the site. User might interact and click and say, well, this recommendation is not good or this recommendation is good, right? Something of that nature. So where does that go? Since whole ecosystem of tracking, this is an excellent question. You can tracking in terms of it's real time. You want it to be real time. For example, you recommend something, you want to know if the user agrees with your recommendation and the user thinks the recommendation is not good, right? So we have what is called a tracking system, independent from the Hadoop big data platform as such. You got to instrument your website, your application pages, and native apps to instrument what is the user clicking, what is the user trying to do. Those are the events you're collecting. Yes, those events are coming into Hadoop and you're running a MapReduce. And producing the results are going back to the site. User gave me feedback. The feedback is coming back to this. Now you might ask, this whole loop might take several hours before the results are seen there. And you are right in that. It's going to take several hours if you want to go through this whole loop out there. Which is why I remember in one of the slides here that I showed that we have an HBase there. By definition, you have HDFS, so you can run a MapReduce if you want. So the tracking that happens, the results that we published here, user giving the feedback, it can come directly here for real-time feeding into recommendations. So that we're experimenting with that too, for a subset of the events.
But for future, if you want your Hadoop MapReduce to work even better and better every day, it's probably better to give that data to Hadoop as an input so you can learn.
Yes, we are giving that. The only reason we are, any data that's coming in, this is the clickstream data. It automatically comes from here back to Hadoop into the system. From there, it absolutely comes back in here. The reason why I was talking about the example of coming here is also if you wanted to instantaneously, the next click, you want to know that, it comes there too. Yeah. Good questions. Yeah.
So, getting to what you were saying about Starbucks business evolving for recommendations and that sort of thing, going to your variety paradigm for your data, is there a system to prioritize what kind of data informs that recommendation? Something social versus a clickstream?
Yes. So question is there a process and system for prioritizing what data sources we bring into use cases? The answer is absolutely yes, right? Remember I've talked about 4 use cases: recommendations, social interactions, business analytics, and the customer 360. There are different business teams, different business units that prioritize and work on these streams. And that team identifies within that to say, in order for me to effectively give recommendations to there, I need social, I need transactions, I need clickstream, for example, right? Now, whereas a different team would say customer 360, the team that's working on customer 360 will say, in order for me to effectively understand the customer, I need not only, I need yes clickstream and I need transaction, I'm just making this up as an example. But I also need Axiom, for example, for user segmentation. I also need logs. So what happens is these requirements funnel through, and then we get prioritized in terms of what sources need to come in first. Eventually everything will come in. If at the beginning you have to go through some prioritization. More questions? Yes? You good? No, it's okay. Then sit.
So, okay. The import there, the export there. Do you run those in the same clusters that you have running for your nodes, or do you have an application that just gives data to HDFS? And you have to take it from there?
So we have separate nodes. John actually in fact has a talk this afternoon at 2 p.m. He's going to go into detail about how those adapter itself work. Yeah, it might actually answer your question in detail there. But the short answer is, yes, the nodes on which the data adapter runs can be dedicated. Data adapters ingest and import the data to separate from the nodes actually that run the MapReduce jobs for your aggregation. But I would encourage you to attend the 2 o'clock thing to get more details on that. Yeah. More questions? Hope it was helpful, useful. Thank you. Thanks. Yeah, don't forget to leave your business card. I think we can pick the 2 winners. I'll email once I know the email address. Thank you.